Okay, everybody, getting pretty close to time to start, so I figured I'd start recording, make sure everybody could hear me. If you can, we're going to be having a Q&A at the end of this. Usually those are fairly short, but down in the question section there, if you guys can hear me, just do a quick post. Make sure I'm not just talking to myself the whole time. Okay, so we're going to do this a little bit differently here. I'm going to launch this poll. You guys tell me yes or no, can you hear me? Okay, good. So that means that at least a few people can hear me, and that's good enough. We can go ahead and get started here. I'm going to throw my my PowerPoint up here on the screen. Okay, so if you haven't seen one of these webinars before, the format is generally I'll be going through a PowerPoint presentation, talking over the slides. My format is giving you a little bit of information conceptually about what the technology does, and then show you the configs, and then at the end we'll do a lab to demonstrate it, show it in the wild how it actually works. So here we go. Today's webinar is about iOS IPS. This is targeted at network engineers, security engineers, and hopefully people that are prepping for their CCIE security lab. It's certainly a topic that's fair game for the lab, and even if you haven't ever used it in the real world or don't intend on ever using it in the real world, it's a good thing to know about for the lab itself. So here's how we'll be doing the webinar. I'm going to give you a quick intro to the technology. Then we're going to go over the IPS concepts. And some of those are general IPS concepts, and some of them are going to be specific to Cisco's IPS implementation. We're going to compare iOS IPS to the iOS appliance boxes. We'll take a look at the configuration commands like I mentioned earlier. We'll see an example config of how you might actually set this up on a real router. And then at the end we're going to be doing a demo. I'm going to set up iOS IPS, do a real quick demonstration of how signatures work, and then at the end we'll do Q&A, so if anybody has any questions about anything about the technology, the CCIE lab, or life in general, whatever we want, we can do the Q&A. At the very end, Jerry, one of our sales specialists, is going to do a quick presentation, and then we'll close the webinar out. So let's get started here. So iOS IPS, it is not a module that you stick in the back of your router. It's a software add-on, and it allows you to run an inline IPS on an iOS router. So this is going to use the pretty close to the same signature set as your appliance-based IPSs, and it's going to report the same way as well, meaning you can use IPS Manager Express, IME, SDM, Cisco Configuration Professional, etc. To set the thing up. Uses syslog and SDE. We'll get into that later. And the main point of it is to have it be a lower cost alternative to the IPS hardware appliances themselves. So here's the requirements for running this. You have to have the right iOS image, and by right, that varies from router to router. Usually it's one of the advanced images, so the advanced security, advanced IP services, advanced enterprise, etc. Unfortunately, those tend to be the little bit more expensive licensing-wise iOS images. And if you have a question about whether your particular router can run it or not, you can use the software compatibility check utility that Cisco has on their site, or there's a matrix of, for this router, you need this iOS image out there. You can find it just by doing a Google search. If you can't find it on Google, after the presentation, you can always email me or post on securitye.com, and we'll get you a link to the site. So this does work on most routers, all the way from the 800 series up to the 7200 series. Works on the newer, 2900s and so on. After you have all of that stuff, the right hardware model, which again is almost any iOS router, and the right iOS image, you do need a special software license for the support and signature updates. So it's possible to run this thing, but if you don't want to use signatures from 10 years ago, then you'll have to buy a license for the IPS signature updates as well. So when would you use this IPS? Generally, this isn't going to be a data center or a large enterprise type of thing. It might be used in an enterprise, but where it's going to be deployed is usually small offices or branch offices. So that can be used if you have a WAN link or VPN tunnel, something like that, back to your HQ. You can run the IPS on the branch router to filter traffic from and to the corporate HQ, as well as from and to the internet. So here's just a quick little diagram of where you might deploy this. It's going to be deployed on the branch office router, not over here at the corporate headquarters. Probably you're going to have a purpose-built IPS appliance box somewhere back here. But out here at the branch office, this is typically where this is going to be deployed. And again, you can use this pretty flexibly. You could use it to filter traffic that is going from your branch office where your actual users are, the people that are likely to get infected with worms and viruses and so on. You can filter out the traffic as it goes to your corporate network. You can also use it as a typical IPS after the firewall. Use it to filter out traffic that might come from the internet as well. Okay, so on to the general IPS concepts. Let's talk about the difference between an IDS and an IPS. An IPS, or intrusion prevention system, is actually sitting inline in the flow of traffic, like it says here. And an IDS, or intrusion detection system, is not sitting inline. It's just receiving a copy of the traffic. Of course, the benefits there should be obvious. If you're actually sitting inline in the flow of traffic, you can take actions, and that might be alerting or actually dropping packets. You can take those actions on the actual traffic as it's traversing your network. An IDS, generally the way it works is you've got a span port, a span session set up on a switch, and it's making a copy of the traffic. The IDS can still detect stuff that way as the destination port for a span session, but it can really only do things after the fact. It can alarm after something happens. It can maybe do things like sending a TCP reset, but the initial attack has already gone through. So an IPS is generally considered superior to an IDS. The cons of an IPS is it is actually sitting in line in the flow of traffic, so if it gets overloaded, you might be dropping packets or not inspecting all packets. You might be affecting latency and things like that. But in general, if you design your network, design your IPS installation well enough, that's not going to be an issue. You buy a big enough box. So iOS IPS is only an IPS. It does not have an IDS mode. It can't run as a span session. It is only working on the actual packets that flow through the router. So know that going in before you decide to buy this. it is primarily or is entirely a signature-based IPS, meaning that it's going to be looking for specific criteria within a packet. It's not going to do net flow, anomaly detection, anything like that. What it's going to look for is, like the example shows here, it's looking for the string virus.exe in HTTP traffic. Fairly specific. It's looking for a string with regex. It's not limited to strings. It could use something like maybe it's looking for 10,000 byte ICMP packets, or it's looking for connecting on a specific port but not using the protocol that's generally used on that port, things like that. But signature-based IPSs like the iOS IPS, they are set up to look for specific criteria. So because of that, the IPS is only going to be as good as the signatures that are written and how well you tune them. You can change the signatures for an IPS. Just be careful when you do so, and make sure they fit the needs of your network. That goes back to buying your license for the signature updates as well. You're definitely going to want to keep up to date because new attacks are coming out daily, weekly, as you're probably aware. So you're going to want to keep up to date with the signatures. It's not a set it and forget it. No IPS is. Okay, so all of these signatures that we have in our signature database are grouped into categories known as signature microengines. And each of these SMEs, signature microengines, deal with a different type of network attack. So as an example, the string TCP engine is looking for, just like the name suggests, strings of text within TCP traffic. And there'll be a string UDP. There's an atomic IP signature microengine that deals with single packet attacks. Each one of those signature microengines and the signatures that are grouped underneath those umbrellas have their own criteria. Obviously, something that's looking for sweeps or floods is not going to match the same criteria as something that's looking for a string of text or a single packet. So again, these signatures, when you go in and look at them, they have different criteria depending on the signature microengine that they're a part of. Okay, so the signatures are great. They're made for detecting things. Signatures, when there's a match on whatever criteria the signature is looking for, and again, that could be a string of text or X number of packets of a certain size, so on. Whatever that criteria is, if it's matched, the signature fires. And that just means it's going to take an action of some sort. So almost all of the signatures out there have the action produce alert. And that just means that an alert is going to show up letting you know that something matched that signature. In addition to that produce alert, there's a number of other actions that the IPS can take, and we're going to see them here on the next slide. So produce an alert, like it says, an alert is generated in the event store. That's going to show up. You're going to know about it either through syslog or SDEE, and again, we'll talk about that later. Deny packet inline just takes that packet, whatever it is, and drops it. So that's the least intrusive of the intrusive event actions. Just drops that single packet. You can also deny the connection inline, and like it says, that denies the packet and any future packets for the TCP flow. And by flow, we mean source IP address, destination IP address, source port, and destination port. So anything else that comes in on that TCP flow is going to be denied. Deny attacker inline is pretty much the most severe action you're going to see. And what that does is It denies that packet and any other packets going forward from that particular source IP that got identified as an attacker. And like it says here, it denies packets from that source for a configurable time. Off the top of my head, I think it's half an hour, but I could be wrong. In any case, you can tweak that as you see fit. But if that a signature with that action fires, the source IP address that's the attacker, all of its traffic is going to be dropped. Reset TCP connection down there. Yeah, it sends a TCP reset with the idea being to drop the TCP session. Okay, so risk rating is how we determine how dangerous an attack is. Risk rating gets calculated for each individual signature as it fires. So there's these criteria that make up the risk rating here. Signature fidelity, and that's how accurate did the designer of this signature think it is, a number from 0 to 100. So if I think it's about 50% accurate, I would have signature fidelity set to 50. Alert severity rating is how dangerous do we think the attack is. And like you can see there, it's fairly limited as to what that can be set to. 25, 50, 75, or 100. Nice even quarters there. So if I think this is a very dangerous attack, I would set my alert severity rating to 100. If I thought it was a not so dangerous attack, maybe I'd set it to 25. Target value rating is how important is the target. And that's configurable by the user. So if you have, say, you're Amazon.com and your web server is obviously very important, the IP addresses of your cluster of web servers you would probably set to 200 for the target value rating. Something less important, you might use a lower target value rating. So all of these criteria get put through a formula, which we're going to see on the next screen, and it kicks out a number from 0 to 100 to let us know the risk rating. So there's the formula. It's fairly simple. It's just all three of those criteria, the fidelity of the signature, the attack severity, and the value of the target, multiplied, and then divided by 10,000. And again, that is just going to kick us out a number that is from 1 to 100. We'll see that when we get to the demo portion of this. So in addition to the individual signatures themselves having actions, the IPS as a whole can add or remove actions from signatures depending on some criteria, and we'll talk about these here. Adding actions to signatures is called an event action override. Subtracting or taking away actions from a signature that fires is called an event action filter. Let's get a little bit more information about these. An event action override, you configure these globally. So it's based on the risk rating, which is that formula we looked at a few slides back. So let's say that we have an event action override that says any signature, and this is how it works. It's not per signature. It's any signature that goes over risk rating 90 adds the action deny packet inline. So if we have a signature, that's an ICMP flood, and it normally, has a risk rating of 75, it fires no problem as long as it doesn't go above 90. Say that we have a target value rating set up for, like I said, a web server that we think is particularly important. Normally the signature would fire with a risk rating of 75, but because it's going against this important web server, it fires with a risk rating of 95. because it went over that threshold, instead of just generating an alarm like the signature was set up to do, globally we add this this deny packet inline, and the packet gets dropped. That's what an event action override does. Now, it is only global. Like I said, I can't stress that enough. It's not per signature, so that means any signature out of the whatever 1,500 signatures that you have in your database, any signature that fires with a risk rating of over that threshold, 90 in this case, is going to have the deny packet inline action added to it. So it's a pretty ham-fisted way of adding actions. It's not very granular. So you got to be really careful when you decide to use that. Okay, so the flip side of the event action override is an event action filter. What that does is it removes actions from a particular event. And you can get much more granular with these, and I'm not sure why it was really designed that way. The event action filters, you can get super granular. You can say if signature 2000 is going against targets within this particular subnet, subsignatures, etc., then remove this action. So as a simple example of that, you could say that we have a signature that is going to fire when it sees more than 1,000 emails per minute, let's say. It's meant to stop email floods. But we also have a mass mailing box that we use for sending out newsletters. In corporate networks, we usually call those spam cannons. You can get an appliance or software that mass emails. So let's say that we want that signature on, and we want it to deny packets for our whole network, except for our spam cannon appliance that's going to be sending out our marketing emails. So what we can do is we can say, for signature 1200, or whatever the signature is that's going to be blocking those email packets, for signature 1200, I see a question flashing over here. I'll get to it in just a second. For signature 1200, if and only if the source is the IP of our spam cannon, then remove the deny packet inline. That would be a use of an event action filter. Also worthy of noting here is that if you have multiple filters, then they get processed from the top down like an ACL, and you can reorder them as well. Okay, so as far as logging and notification, I mentioned this earlier or touched on it. iOS IPS has two and only two methods for logging events, and that's SDEE, which is Security Device Event Exchange, and syslog. Almost everyone in the IT industry is familiar with syslog. If you're not, wow, do you have some Googling to do. But syslog is the industry standard logging method. As it says, it's less secure due to lack of encryption. It just runs over UDP and runs in clear text. Yes, I'm aware that there's encrypted versions of syslog, and you can do things like create IPsec tunnels to encrypt it. But as a basic package, syslog is not encrypted. SDEE, Cisco kind of drove the development of that, but it is an open standard and it's used on other devices. Like Fortinets, I think, use it. I think some Symantec software can use it. It's more secure. It runs over SSL, TLS, and it's just a format and a transport protocol for sending IPS notifications. Whichever one of those you choose to use. I mean, I'd use SDEE in a Cisco shop with everything supporting it. Maybe you use syslog if you're not all Cisco and you just need a little bit more recognized and more supported protocol. Yeah, there's nothing wrong with syslog. But those are your two choices. Okay, so that is all of the kind of foundation work. We know generally what an IPS is and what it does, and have these concepts down for how the Cisco IPS specifically works. So let's talk about the IPS appliance versus iOS IPS. The IPS appliances, as you may or may not know, Cisco offers those. They're a purpose-built appliance-based box. They run a stripped-down version of it looks like some form of Linux. And iOS IPS is just software that runs on a router. So they use generally the same signatures. The iOS IPS is a little bit trimmed down, but it uses most of the same signatures that you would have on your appliance-based IPS. So like it says here, they share most signatures, most event actions. They both use the event action override and event action filters, as well as logging with syslog and SDEE. So if that's the case, why would you want to use the more expensive appliance? And the answer is, if you want to, well, there's a number of reasons, but that third one down there, dedicated memory / system resources to the IPS. The appliance-based IPSs can simply handle more traffic. Again, they're a purpose-built box. They're not also doing routing, also doing call manager, also doing firewalling, etc. They're just an IPS, and the hardware and software on that box is dedicated just to doing that. So in general, they can handle more events, more traffic per second through the IPS than iOS IPS can. They also have slightly more signatures. They have some additional event actions that the iOS IPS doesn't have, like packet capture and sending an SNMP trap. They have interface flexibility. You can run the appliance-based IPSs in a number of different ways. You can do inline VLAN pairs. You can just do strictly inline interfaces. You can stick it in IDS mode and have it just receive traffic from a span session. So you have that flexibility. You can also break off and make multiple signature databases. So you could have one set of signatures for your internal network, one set of signatures for your traffic incoming from the internet. It has the concept of virtual sensors, which, like it says there, is really multiple IPS policies, and again, maybe one for internal, one for internet traffic, or one for the data center and one for the corporate network, however you want to set that up. It also does anomaly detection, and that helps look at traffic patterns for zero-day attacks that just came out and don't have signatures written for them yet, and some more stuff. So the IPSs, the appliance-based IPSs, have a lot more bells and whistles, and are worth it as a purpose-built appliance to put in a data center or a large corporate network, etc. We can't hit everything that they do versus iOS IPS in a short webinar like this. But if you're at all interested or want to be a semi-expert at those, there is as part of the CCNP security, there's an IPS class, as well as Cisco Press has written books about it, so you can get more information about that. Okay, so iOS IPS, the main benefit is cost savings. Yes, the appliances can do more and can handle more traffic, but you don't always need that. Particularly in the case of a branch office type of situation. You have 250 branch offices. Do you need to buy 250 $10,000 to $20,000 boxes, for each and every branch office? Probably not. You don't need to handle that much traffic, and you already have a router at each branch office, so why not just tack on the iOS IPS? So having an all-in-one type box is a good thing, and kind of the point here. So, you have a branch office. Maybe you're running the classic, 2811. You're running iOS IPS. You're running a zone-based firewall to filter out traffic. Anything that gets by that gets inspected by the IPS. Maybe you're also running your phones with that router, QoS stuff going back to the main office. Maybe you're running wireless or a switch module on it, etc. So you can have, a single network device doing everything for your branch office. The iOS IPS pretty well fits into that model. Okay, so that's why you would use it versus the hardware appliance. Now let's talk about how to actually configure these things. Like it says here, many network engineers prefer to configure the IPS through SDM or Cisco Configuration Professional. Normally, when I'm presenting these classes and talking about GUI stuff, so I'm pretty hard on the GUIs and people that use them. But the IPS is one of those things that is a lot easier to configure through the GUI, and it's certainly a lot easier to monitor, much easier. So in the real world, do you use SDM? I wouldn't. Configuration Professional is a little better. The issue here, though, is probably, I don't know if everybody here is prepping for their CCIE security lab, but you can't use the GUI, either SDM or Configuration Professional, in the lab. So you really need to know how to do this from the command line. And once you get it down, it's fairly quick and easy to configure. You can bust this config out in 5 minutes as opposed to spending 5 minutes just trying to get SDM to work or something like that. So I'm not going to show SDM or CCP at all in this. We're gonna do just the CLI. So there are some prerequisites for running this thing. We mentioned already that you need the right router running the right iOS version, all these licenses, and so on. Configuration-wise, you also need to do some setup before you can start with this. You don't absolutely need to create a directory in Flash for the IPS files, but it's going to keep your Flash a little bit neater. It keeps all of your configuration and they call a delta file, which is the signatures from when they started versus how you've tuned them. There's quite a few files that make this up, as we'll see when we get to doing the demo. So it's a good idea to use the makedir command to create an IPS directory, so you can dump all those files there. You're also going to need a valid signature definition package. You download those from Cisco.com. So you can copy those with the copy command. Copy TFTP flash, select the right file name, and so on. Get it copied over to the router. The IPS usually ships with a default signature definition file, and it's usually really small, does not include very much at all. So you're going to want a current, the most current signature definition file you can find, and get it on Flash. Finally, you need Cisco's public key, and we're going to talk more about that right now. Those signature definition files that you download from Cisco are signed with a private key, and before they get loaded, they have to be verified with Cisco's public key. The reason for that is Cisco does not want a bunch of unauthorized signature files out there that maybe have signatures tweaked to let particular attacks through, or maybe just an amateur person thought they were doing a good idea writing signatures, but it doesn't work well, etc. So the router is only going to accept these package files that are signed and verified with Cisco's private and public keys. So you got to paste this key into your config. You can find it all over the internet. Like it says there, just go to Google, put in iOS IPS public key, and you'll get exactly what you need to paste into your router. You don't even have to type that crypto key pub key chain command. Usually that's actually in the file that you copy and paste in. So yeah, here's what happens when you try to load a signature package without pasting the key in. You'll get this error message about invalid digital signature, key not found. That lets you know, oh, I forgot to paste in Cisco's public key. Okay, so here's the prereqs that I talked about. First we've got the makedir IPS, and that is just going to create a directory in Flash called IPS. Copy TFTP to Flash. Again, that's copying my signature file that I downloaded from Cisco from my computer over to the Flash on the router. And then this is what you'll get when you do that Google search to find the public key. It's just the commands that are going to paste in the key. I only showed a single line here. In reality, it's, I don't know, 10 or 12 lines of strings of text. I just cut it so it fit nicely on one screen. But we'll see that when I actually do the configuration demo. But that's what pasting the key in looks like. Okay, so we've done all of our prereqs. Now we can actually go about configuring the iOS IPS. So like it says here, most of the basics are done with IPS commands. We're going to be setting up the location where our configuration and signature files will be. That's that directory we created with makedir. And that is set with this command down here, IPS config location, and then the URL where that directory is, in this case, Flash IPS. So what we did there was set up where all of our configuration files and everything will be stored. So now we're going to create and name this IPS rule. We're going to use that because when we actually apply it, that's what you set on the interface where you want to do your inspections. So real easy command, IPS name, and then whatever you want to name your IPS rule. So I named it Cisco in this case, but as it says here, you can also attach an ACL to this, IPS name, Cisco, list, and then the number of the ACL. And what that does is that will limit anything that matches a permit statement in the ACL gets inspected. Anything that doesn't does not get inspected. So it lets you limit what traffic gets filtered if you decide to do that. A lot of people, especially if they're filtering traffic from the internet, you might not use a list because you want all the traffic to be filtered. But let's say you were just interested in filtering traffic from and to your corporate network. You could have an ACL, say only from 10.1.0.0 going to 10.2.0.0 as an example. So you can use that list if you want. Okay, so like it says here, that is really all you need configuration-wise. You could just go, I want to apply this to an interface and start doing my IPS, start inspecting traffic. But there are some other options to consider here, and I just did an IPS and hit the question mark so you can see what they are, and we'll talk about some of them like auto update and so on. Okay, so syslog is going to be the default method of notification. If you want to use SDEE, you're going to type in IPS notify SDEE. Syslog will still be on at that point, so if you want to turn syslog off, you would do a no IPS notify syslog, and then you'd just be using SDEE. Going back, we have this fail here. Specify what to do during any failures. And what that means is failures of signature microengines or the IPS software itself. If that fails, it's set to fail open by default. Generally, that's what you want to have happen. You don't want all traffic on your router to just stop because the IPS engine crashed. But if you have a more restrictive security policy at your for your installation that says if it's not being inspected, it's not going through. If that's the case, you can type IPS fail closed. Fail open is a default, so you can't even type that, but you can type IPS fail closed. And again, that just means if the inspection engines goes down, anything goes wrong with the IPS software, traffic's not getting through. If you use the deny flow inline or deny attacker inline, an ACL gets created to drop that traffic. And like it says here, those ACLs are normally created on the ingress interface of the offending traffic, meaning that if the traffic came in on fast Ethernet 00, the ACL would be applied to block at fast Ethernet 00. For the most part, that's exactly what you want to have happen, but like it says here, if you're load balancing and if the IPS rule is applied outbound, that might not block all the traffic. The other load balanced interface might use it. So you can use the IPS deny action IPS interface, and that would apply the ACL to the interface where the IPS rule itself is applied, not where the traffic actually came in. That's a special case scenario, and one that you probably won't see, but just in case it happens, there it is. Okay, before we move on, the auto update command. It sounds like a good option, and it is, but say that you have, again, 250 of these iOS IPSs, out on your enterprise. Each branch office has one. You don't want to have to update them manually each time a new signature engine comes out. So the point of this is it would be nice if it actually went out to Cisco's site and downloaded the signature updates, but that's not what it does. You set it pointed at one of your internal servers, and you download the signature file once from Cisco, and then at a predetermined time, your iOS IPS boxes will connect and attempt to automatically apply these new signatures. So here's an example of this. When you do IPS auto update, it drops you into a sub configuration mode, and you say, I'm going to be downloading from the URL TFTP 10.1.1.1. I will have this occur at 2 a.m. 1 through 31, and on the day of the week 0. If I have the syntax correct there, we can take a look at this when I do the demo. But I believe it starts from Sunday, so 0 would be Sunday, 1 would be Monday, and so on. Again, we'll take a look at the format or the syntax of this command to make sure I just told you right when we actually do the demo. Okay, so after you're done setting all of your fail open or fail closed and your notification method and all that good stuff, here's how you apply it. You just go to an interface like we show here, serial 001. IPS, the name of our IPS rule, Cisco in this case, and the direction in which you want to filter, incoming, is usually what gets used. And you can see as soon as that gets typed, it starts building all of these signature micro engines. It's unpacking the signature file and compiling the signatures. So yes, now you have turned on your IPS and you're actually set up and filtering traffic in line. You might notice here, though, that all it really did was compile 3 signatures, one of 13 engines, and that's all it did. The reason why that's happened is because, and I may be getting ahead of myself. I think I actually have a slide for this. So let's take a look here. Yeah, the atomic IP signature micro engine got compiled, and only 3 of the SIGs compiled. So we haven't yet loaded a signature package, and Cisco does not have it automatically use really large signature packages because it's very resource intensive to compile all of those signatures all at once, and it's very possible that you can crash your router if you turn them all on at the same time. That's pretty well documented and pretty well known, especially in the lab, or if you're familiar with Cisco 2800 routers. I would guess that that's the most common branch office router in the world. If you turn on a full signature package all at once on a 2800, like half the time it crashes the router. So the general best practice when you do this is to apply the rule to an interface like we just did, let it load up the 3 or 10 or however many default signatures you have, then go in, retire all signatures, set the IPS to retire all your signatures, meaning they won't compile. Then you can load your signature package, which we'll see the command to do in just a second. And then you can turn on category by category so that, again, you don't crash your router. Okay, so we go interface serial 000 or whatever interface we want this thing on. Type in IPS Cisco in. It compiles the limited number of signatures. Then what we can do is go to IPS signature category, category all, retired true. So that turns off all the signatures. Nothing's going to compile when we load our signature package. It is kind of important to note here that after you do that or do any work with signatures at all, you have to exit back out to exec mode for those changes to take effect. So, and you'll get a prompt when you do that. You can, whether you hit Control-Z or type exit a few times, it'll say, do you want to apply these changes? So once we've retired all of our signatures, we're ready to load up our signature package. And this has been the source of much confusion. Looks like I don't even have an example here, but it's using the copy command, and you copy from your signature file to the destination of IDConf. And basically what you're doing with that IDConf is that's the running configuration of the iOS IPS. So you copy the static signature file to IDConf. As soon as you type that command, and again we'll see this when I do the demo, it is going to start loading and compiling all of our signature engines. And this is where, if you forgot to do your category all retired true, this is where your router crashes. So again, I'm stressing this because I've seen it several times in the real world and plenty of times in a lab. Make sure that you retire all of those signatures before you copy from the signature file to IDConf. Okay, so let's see this work in the sort of real world, in the lab at least. I got a little bitty lab set up here. It's only 3 routers. What we've got is a router 1 in the middle. That's going to be our IPS box. We've got router 2, which is the big bad attacker guy, and he is going to be launching attacks against our victim, which is router 3. I don't have any IP addresses or information here because it's not important. Really, all we need to know is the victim's IP address is 10.1.1.3. So remember, router 1 is in the middle. That's going to be our IPS. Router 2 is the attacker. Router 3 is the victim. Let me get logged back into my routers here real quick. Got them all configured and left them up, but got timed out of my my session. Okay, so we're all back in. Now I do want to show you an actual signature firing. So as I do this lab, the signature I'm going to use, and it's pretty lame as far as real attacks go, it's simply going to be a signature that detects ICMP echoes. And again, you would probably not turn this on. It's off by default in a real iOS IPS because people ping a lot, and you wouldn't want to block traffic or see alerts every time somebody pinged. But it's a great demo attack because it's easy to produce. So let's just real quick here before we get started. I'm going to ping 10.1.1.3 from router 2, which is our attacker, just to make sure that he can ping through. So right now we're not protected at all. The attacker can launch his quote-unquote attack at will. So here we go. Router 1 is our is going to be our IPS. How about a do show flash? Okay, so since I didn't have my example earlier for the copy command, I just want to show you this is a signature package. This is what a signature package looks like. iOS S series 376 CLI.pkg. That's our signature package. That's what we're going to be copying from. Obviously, if you were doing this in the real world, you would want to copy this over first. I've just already copied it to the router, so it's sitting there in Flash. Okay, so IP. Actually, I mentioned the prereqs here. Makedir flash IPS. I got an error because the directory already exists because I made it earlier. But that is what you would do. So I'm making a directory in Flash called IPS, and that's where I'm going to stick my configurations. If you remember from the prerequisites before, we needed a package file, which I have. We needed the right image, which I have. You got to do a makedir to create your IPS directory. The other thing you needed was to paste in Cisco's public key. So here's what the public key looks like, and like I said, I got this directly off of the internet just by doing a search for iOS IPS public key, and it literally gives you exactly what you need to paste in. Notice at the end you break out of the pasting in the key mode by typing quit. That's not exit like you would normally use in a Cisco router. It's quit. So here's pasting in the public key. And it leaves me in a sub-configuration mode, and I have to exit out of that a couple times. Now I'm back on my global configuration mode. So you can see here, again, what I searched for is exactly what I needed to paste in. Your crypto key, pub key, chain, RSA, named key, the name of the key itself, and that it is a digital signature. Then I type in key string, and it says, okay, go ahead and paste it in hex, which I do, and then quit. So there's all of the prereqs. Now let's go about creating the rule itself. So remember, it's IP IPS. I'm just going to hit question mark real quick so you can see the arguments we can type in after that. The first thing I'm going to do is IPS config location, and it's going to tell me what URL do you want to put it in. I'm going to put it in that flash IPS, which I created earlier with makedir. And again, that's just a pointer saying that all of the files that we use for the IPS, dump them in that directory instead of putting them in flash and you know, making a mess of our flash. Okay, so I set up the config location. The other thing I mentioned that we were going to look at is the auto update, so that I again made sure that I gave you the correct syntax. So occur at minutes at the top of the hour. I don't care about minutes, so I'm going to put in 0. Hours of the day in a 24-hour format. So let's say I want to update at 2 a.m. Days of the month. So 1 through 31. This could happen any day. On a Sunday, it would be 0, or any day on a Monday, or Monday through Friday, if we do it that way. So that's the syntax for that occur at. I'm glad my my memory works somewhat decently. Okay. Then it's telling me URL needs to be specified. I didn't set up a URL because we're not really going to do auto update. All right, remember that fail open is the default, but I could set this thing to fail closed if I wanted. I can also do IPS notify, and let's say that I want to use SDEE, and I want to do a no IPS notify syslog. How about log? Okay. Now earlier on in my config example that I had on the PowerPoint, it showed that I first applied this thing to an interface and then retired everything. You might be thinking, why can't I just go in right now with the signature category command and retire everything before I even put this on an interface? And that would be logical. Category all, retired true. Okay, great. So it tells me applying category configuration to signatures. So I just wanted to check there. So everything's off at this point. Let's go to an interface. Serial 001, like we were talking about. And IP, oh, did I not even create a name yet? Getting a little ahead of myself. IPS name Cisco. Okay, so I've created these IPS rules. Interface serial 00, and let's just make sure we're doing this on the right interface here. Remember, R2 is the attacker. He's on serial 001, so interface serial 001. IPS Cisco in. So I've put my rule on the interface, and nothing happened. Show IP. What's happening? What's happening? There we go. Okay, so you'll notice that shortly after I typed that, it started building the signature engines and compiling signatures. You'll also notice that unlike what I had in my example on the PowerPoint, it loaded a lot more signatures. Here's some string UDP, service HTTP. It loaded 600 signatures. That's good that it didn't crash the router in doing this. So you'll also notice that even though I retired everything, a lot of these still built and loaded. So I'm assuming it did this because I had some previous configuration in that IPS directory. Normally, it's just going to load the atomic IP engine. Okay, so the show commands for this, the IPS is now running. So show IP, IPS, and you can see you can do all to get all available information. You can look at signature categories, your event action rules, which are the event action overrides and filters. So let's just look at all. So it gives us some information here. Tells us, oh, it only did load 2 signatures, so that's good. And a bunch of signatures are inactive. It's set to fail closed. It's running our IPS rule of Cisco on interface serial 001 in the inbound direction. And it tells us that category all is retired true. Okay, so great. Now we have our IPS up and running. Let's say that we want to turn on rules, which we do. We didn't show this in the configuration section of the PowerPoint, but here's how you do it. IPS. You could go to signature category and turn on the different categories, but in this case, for the demo, I just have a particular signature in mind that I want to turn on. So IPS signature definition, signature 2004, which, by the way, if you're going to take a test, you better get familiar with signatures 2000 and 2004. They're 2000 is echo reply and 2004 is echo, so they will alarm on ICMP ping traffic. They're very often used for testing both Cisco written tests in a lab and so on. Okay, so I'm in this signature. What can I do with it? It tells me that I could change the alert severity if I wanted. I'm going to leave it alone for now. What I want to do is go into status and have retired false, because remember, everything is retired. And I'm going to have it be enabled true. So this is basically just turning this signature on from the command line. Now, remember earlier that I said nothing's going to happen after you tweak signatures or do categories or anything like that till you exit out. I hit Control-Z. It says, do you want to accept these changes? I'll hit Enter to confirm. And now it's going to build that signature within that signature microengine only. So again, it's not going to, dump the whole router's CPU and memory into compiling thousands of signatures. It's just going to do the one that I turned on. Okay, so I have this on now. If I do my show IP, IPS all again, oh, looks like it might have been on before because it didn't change the number of active signatures. That's fine. Let's jump on our attacker router here again, and we're going to ping over to the victim 10.1.1.3. Now, the IPS didn't really do anything, right? I was still able to launch my attack. I can still ping to my poor victim router. And you notice that router 1, it's not showing anything. So it didn't look like the signature really did anything, right? Let's do this now. IPS signature definition, signature 2000 or 2004 rather. Engine sounds like you would change what signature micro engine it's a part of, but really it's not. This is where you set what actions are going to take place. So event action, I'm going to set this thing to produce an alert and to deny packets in line. I'm going to exit out and accept the changes. And again, still just have 2 active signatures. You know, let's before we do this, let me do a show IPS signatures. Not what I was looking for. What I'm trying to do is look at the signature itself to make sure that it's on. It's under signature count. This is just going to tell us what's how many total SIGs are out there. Signature engine. Yeah, there's a way to show the SIGs that are loaded. How about it's not the one I want either. Sorry for thrashing around during the demo. I wanted to show that the signature itself was active. Show IPS category. That's what we looked at before. Well, that's fine. I don't want to waste your time thrashing around looking for this. Notice that this time when I repeated the ping, it's not going through. Obviously, that means something is happening. So I turned syslog logging off, right? Let's do this. IPS notify log. So SDEE is on, but I've also turned syslog back on. Let's go over here and repeat our attack. So now that syslog's back on, and now that I have, or I already had logging console turned on, you can see that the signature is firing and doing something. So here's my signature, 2004. That's the one that we turned on. Severity 25. That's the attack severity rating. It tells us attacker and victim, or from and to, and it tells me what the risk rating is as well. And it fired, 5 times, 1 for each of those echo requests that went out. So, there you have it. That's just a quick demo of how to configure a signature, how to change the event action. Again, it's under the engine portion under signatures. You can also turn signatures on, like we mentioned, by using IPS signature category instead of signature definition. So I could say, how about category email? I could say retired, false, exit out. There's going to be a short pause here because, again, it's got to unpack all those signatures and compile them. Now imagine doing this, and right now the memory and CPU are churning. You'll notice that there's multiple engines involved here. When this happens on a larger scale, when you load like the whole signature package all at once, this is the thing that can crash your router. So it's definitely not fast here, and it's even slower and more painful looking when you do it from SDM, for example. It just sits there saying loading with a little thing going back and forth, and you might as well go get up and make yourself a sandwich or something. It takes a while. So look, there's some failure to compile regexes. It's going into different engines, and then finally, just from that one category, I get out. So again, I just want to stress it again. If you're taking a risk if you load category all and say retired false, because it's really resource intensive. So hopefully that's clear. Okay, here's what we didn't show yet. IPS event action rules. You can set the target value rating. Again, if we have a particularly important target, let's do that. Target value, mission critical, target address, 10.1.1.3. Okay, so I've now said that our victim, router 3, is a mission critical or very important target. Again, I have to exit out again to apply the changes. Let's repeat our attack here again. Remember, before that signature fired with a risk rating of 25. You can see now that it's firing with a risk rating of 50. It shows it right over here, risk rating 50. So the point of that is that you could have this be more mission critical, bump the risk rating up, and then set your event action override to deny the that particular traffic, and that generally works pretty well. Like say that your event action override is apply the extra action, deny packet inline to anything with a risk rating of 90 and over, and then set it to be mission critical. Most signatures that are firing against something that's set to mission critical are going to go up to 100, and so that stuff would be dropped. So that can be a really useful tool. I guess that's it. We don't have a ton of real world demonstration we can do here in just a little tiny lab like this, without penetration testing tools or anything like that. But this gives you the basic idea. To kind of summarize here, you do your prereqs. That's creating a directory where you're going to stick your IPS files. You got to copy your signature package over. You got to paste in the Cisco public key. From there, you do whatever IPS configuration you need to do. Create the rule set name, IPS name Cisco, and then apply that to an interface. Once you have it applied to an interface, always remember retire everything before you go about and load your signatures. And by that I mean this command right here, copy flash iOS s whatever .pkg to idconf. This command right here, and again, I know we didn't have an example in the PowerPoint, but this is a killer on the CCIE lab. If you go through, do all the configuration, you have some basic signatures already done, but forget to type this command, you're getting no points. So make sure that after you're done with all your configuration, you type this command, copy flash, whatever the package name is, to idconf. And again, that's copying the new, most updated, signature file that you have. You're copying that to the running configuration of the iOS IPS. Okay, so that command right here, that's kind of the gotcha that I wanted you to know about. Everything else, hopefully I showed well enough and it was clear. We'll open this up for Q&A now. I know that because I can see somebody using the chat portion. There's a chat and a questions, but anybody that that wants can type a question in that way. I see that also we have Ron Nutter here. Hi, Ron. He was in one of my previous classes. He's had his hand up for 54 minutes, so you can ask the burning question now. Maybe you just wanted to tell me earlier that that you couldn't see the slides. Okay, so I see a bunch of people saying they can see the PowerPoint. So you're going to post this somewhere later for the slides. The video and everything will be posted. I'll talk about I'll talk with the folks back at the office about making the slides available somehow. So the first part that you missed, you can find. I would like you guys to have that. I know that looks like I screwed up and didn't hit the play button. I hit the record button, but not the play button, I think is what happened there. Okay, and Jerry was saying that he lost some audio. Did anybody else lose audio and miss out on anything? We got another question here. Does the IDSM and IPS, are those the same product? Yes and no. IDSM is the blade that goes into the 6500s. It uses. You're not muted, Jerry. I could hear you.
I was looking for Don Reeves.
Sorry, guys. Let me mute.
Laura, is
Jerry
Don
here.
Reeves out there? Oh crap.
Okay. Sorry about that. So the IDSM is the blade, the IPS module that's just a blade that goes into your 6500. It uses most of the same concepts that we've gone over here. It's more similar to the IPS appliance. It's not software based at all like the like iOS IPS is. So yeah, the IDSM blade is much closer to the hardware appliances than it is to iOS IPS. The configuration is different as well. Okay, so is there training available on IDSM? Yeah, the CCNP security, or the CCSP, the IPS class, does indeed have a section about IDSM. There's not a specific class that CCBOOTCAMP has on IDSM. However, say that your company bought, 10 of them, and you're going to put them, use 6500s as distribution layer switches or something, and you want to know how to configure that. We do custom classes. It's likely that would be taught by either myself or our other security instructor. I've had personal experience using IDSMs. I ran those at one of the enterprise shops that I worked in, so I'm fairly familiar with that. So no, there's not an IDSM specific class. Yes, we could teach you a custom class, but there's a good bit of information about IDSM in the CCSP/CCNP security. Does anybody else have any questions? I'm monitoring the chat thing down here, or the question. Okay, if there's no more questions, yeah, I can't see who said that, but thanks for a great presentation. Thank you for showing up. I always want to make the point before we leave these things that I'm a moderator and very active on securitye.com. That's a CC Bootcamp run, but not a marketing type forum for people that are prepping for their IE lab, as well as other tests. And like I said, I'm very active on there. I check and reply to stuff daily, and so does Tim Rowley, who is our other security instructor for CC Bootcamp. It's a really active forum, even outside of just me. There's a ton of people that participate there. It says here, do we have to load the signatures in the CCIE lab, or are they preloaded? By preloaded, do you mean are they sitting in Flash? I can't say one way or the other for the NDA stuff, but what I will say is that if they ask you to do something on the CCIE lab, they always give you the resources you need to do it, assuming that you know how. So I guess what I'm getting at there is maybe they'll already be on the router, or maybe they'll be on a TFTP server and you have to copy them over. But either way, you'll have what you need to complete the task. Okay, let me if there's I guess are there any more questions for anybody? I want to turn this over real quick to Jerry so he can make a short presentation just about kind of how to get more information here. Before I turn it over to him, I want to say thanks to everybody for showing up, and once again, you can see up here the forum securitye.com. If my speaking isn't clearly enough, that's the URL that you'll want to go to. And again, that's you can always email me, but with Security IE, it's not just me. There's a ton of people on there prepping for their CCIE lab. Most of them give great information, so that's a really good forum to go to. So let me turn this over to Jerry here, so he can make a short presentation. All right, Jerry, you are unmuted.
Okay, thanks a lot. First and foremost, special announcement. Any of you who are going to Cisco Live and are interested in CCIE Voice, or if you have colleagues that are, we have a great presentation being headed by Larry Metzger, our CCIE Voice 360 instructor, specifically on plus dialing, just because now the new CCIE Voice track is going to expect you to have an acceptable understanding of plus dialing technologies. So we are going to focus on two specific scenarios. Number one, configuring plus dialing. Number two, troubleshooting plus dialing. I've been told it's going to be Monday, July 11th, the first day, from 1 p.m. to 5 p.m. at Mandalay Bay. If you are interested, or if any of your colleagues are interested, please go to www.ciscolive.com to sign up. There is limited availability on the slots, and I'm trying to get an extension on the sign-ups as far as the deadline time. So if you are interested, or if you have a colleague who's interested, please have them go there right away to sign up. Once again, that's going to be Monday, July 11th from 1 to 5. Secondly, for all of you who are going to Cisco Live, we will be there. We will have our booth. It's booth number 1939. You can enter from all four sides. Just look for the red and black signs. We will have on display our latest self-study materials, the study guides. It is an all-hands-on-deck event for us, so you'll see everyone from Cisco Live there. You'll see Steve, you'll see me, other instructors, as well as other Cisco education consultants over there, as well as displays for things like our mobile course on demand. Lastly, if you want to view the video presentation of this, go to lms.ccbootcamp.com. Starting tomorrow, we will have it available on streaming video, probably up there for a good 1 to 2 weeks. I am looking into the slides that weren't available during, I think, the first third of the presentation to see if I can have them available. If you'd like copies of those and I can make them available to you, please email me. My email address is jerry@ccbootcamp.com. And lastly, we do have a CCIE security training special for only $1,995. You'll get 200 hours of rack time. You'll get our technology-based workbook, which has a series of technology-based labs, as well as our full 8-hour labs on our advanced lab workbook. You also get access to our videos on demand. It was a series of CCIE security lectures that we did the past year, going over various topics, plus 200 hours of rack time, and more importantly, you'll get 5 days in the instructor-led CCIE Security Advanced Lab Bootcamp. Each day you'll be focusing on an 8-hour lab and having an instructor who himself is a CCIE security, looking over your shoulders and fine-tuning everything as far as your understanding of the core technologies, all the way through to final configurations, to make sure that you come in there thinking at the advanced level and leave thinking like the internet working expert. If you'd like more information about that, once again, feel free to contact me. Email address is jerry@ccbootcamp.com, or you can call me toll-free at 877-654-2243. Thank you so much, everyone. Thank you, Steve.
All right, yeah, that's the end of the webinar. Once again, I want to say thanks for everybody that attended. Just checking real quick to see if there were any questions I missed. I guess not. Again, if you do have any questions, securityie.com, or like Jerry said, if you do plan on attending Cisco Live, I'll be there in the booth almost all the time. So feel free to stop by and say hi and meet me and everybody else in person. So that's it. I'm going to stop recording and stop presenting. Thanks again for everybody that showed up, and I hope you got something out of this.